Good afternoon, everyone. We're back again. Good to do to finish up what we've actually started yesterday. So we're gonna continue with limits. So just a refresher. Remember we talked about the limit is a value for function for which a function approaches when the input gets nearer and nearer to a certain value. So let's take a look at this example. We're gonna look at the cubic function. So let's see the limit of x cubed as let's say x approaches 3. So remember we went through yesterday the process of finding out the value coming from the left and value coming from the right. So what we can do today is make a justification that we can find the limit of any polynomial, because a polynomial is continuous. We have not gone to what that means to be continuous as yet, but that will be a great start. So if we can think about what a polynomial is, it will be in this form where we have the a-nth term x to the n plus a to the n minus 1 x to the n minus 1 plus ta 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 plus in this case we're gonna have a1 to the x plus, of course, x is 0 is 1, so going to be a0, which is a constant. So in this case, this is a polynomial. So any function that takes this form of a polynomial actually would be continuous. So therefore, to evaluate this function, we simply go ahead and plug the value that the function approaches, which in this case is 3. So therefore, we're going to have 3 cubed. That's equal to, what's the cube of 3? So it's going to be 27. Oh, nice. So therefore, the limit of this function equal to 27. So that's just a refresher. So what we can say is that as long as the function is a polynomial, so we can say this is true for any limit question, as long as the function is a polynomial, because it can get messier when we're going to be looking into rational function that takes the form of this case right here. F of x equals to p of x divided by q of x, such that p of x and q of x are polynomial function, right? So they're polynomial function, and in this case, of course, we know that q of x cannot be 0. Alright, so what we're going to be looking into a little further now actually is some basic algebraic expression that we need to know, of course, in order for us to be able to really use limits. So we're going to take a look into that right now. So the first one that we're looking into, some basic rules actually. The first one, let's say, so what we're going to use, we're going to say the limit of a function with a constant multiplied by the function c of f of x such that x approaches a. Right? So now this itself is also equal to, since c is a constant, c can be placed in front of this. So therefore we can just find the limit of the function as x approaches a for f of x. So if we look at it, excuse me, look at an example now, pretty much, so you can see how this works. This can make a big difference here. So if we're looking for the limit of x approaches, let's say 5 for the function 4x cubed, right? We can do this just as we did in the first property there that we just derived. We're going to have x approaching 5 as x cubed. Now, this right here, we just did this, right? X cubed is a polynomial function, so therefore we can simply find the value of that function by plugging that in. So therefore, we're going to have 4 times 5 cubed, and that's going to be equal to 4 times 1, 25. And what is that equal to? Use a calculator. Come on. That's going to be 500. Right? So what I want us to consider once again actually, if a function has a coefficient in front of it, that coefficient can be pulled to the front here. Right? So there's properties that allows us that. We're not going to get deeper into that. However, we just want to make sure that it's actually clear that we have that property available. Okay, so take one look at it. We're going to go to the second basic algebraic property for dealing with limits. Alright, so the second one now. Now, if we have two limits, right? Say we have the limit of a function as x approaches a for f of x, and that limit is equal to, let's say, L1. We have a second function which is limit of x approaches a, so they're both approaching the same thing. However, they're going to actually be for two different functions. Call this one g of x and call limit L of 2. Right? So this property allows us to combine them if we're given the function to find the limit of x approaches a. Right? We're going to do the limit of f of x plus g of x. See, the amazing thing about this is that when we find this limit of these two functions as a sum, we'll actually have the sum of the limits as well. So if we know each limit, we have to find the limit of the sum is also the sum of the limits. So we want to always keep that in mind when we discuss limits. These simple algebraic properties will be needed later on down the line. So let's continue to work on this. So we're going to prove the third property as we go now. The third property that we're going to have now is going to actually be for the functions. In this case now are going to be different. So two of the same function that we have. So if you forgot the function what they look like, let me go back here so you can see the both functions, those two functions right here. If we have to find the limit of these functions, x minus approach a, and this limit of f of x multiplied by g of x, that's equal to limit of the first function times the limit. So it's also the product of both limits. So this is a very interesting thing. If you take a look at this, we can actually use these properties to simplify a lot of other complex problem. So what we're gonna do real quick, we're gonna look into some examples on our next videos that would actually help us explain these problems, or better yet, let's do some of these examples right here right now using the same properties that we just learned. Alright, so let me get a brand new board so I can actually have some more space so we can get some of these done. So let's go. Alright, so remember that if you think you have any questions, feel free to leave in the comment section. I'll be able to respond for you, and then, that'll be great. So let's take a look at this first example that we're going to have right here, right now. Well, we have two functions. We're going to have the, let's say, the limit of, yeah, limit of 4x as x approaches 2, and another function here, the limit of approaching the same value, which is 2, of 5x. So if we're asked to find the limit of, so it says, let's say find the limit of, this is g of x. Let's say that's g of x, and this would be my f of x, right? That's the question. We're trying to build one here from scratch, so using examples. Find the limit of f of x plus g of x, right? So we just looked at the property, and the property tells us that the limit of this function is simply the sum of the limits. So therefore, the limit of the first function, we can say that's a polynomial, right? So therefore, the limit of 4x as x approaches 2, since it's a polynomial, that limit is basically 4 times 2, which is equal to 8. Then the next thing is the limit of the other function, which we're going to have the limit of 5x, also a polynomial, so therefore 5 times 2 equals 10. So therefore both limit, the sum of both limits, 10 plus 8 equal 18, right? So there we go. So that will be the answer to that question. Now, if we had actually went ahead and added both functions first, so let's say 4x plus 5x, we're going to actually end up with 9x. So therefore, the limit as x approach 2 for f of x plus g of x would be equal to the limit of x approach 2 of 9x. So remember, this is f of x, this is g of x, so we added both functions here, and we'll end up with 9x here, and we put the 2 to substitute x, we're going to end up with 18. So the same answer that we got, so it doesn't matter actually. For all these properties, limits will not be that hard for you. So hope you guys like the video, so feel free to give me some feedback, comments, and how can I make these videos better. Thank you.